Hello, friends. In our last class, we have discussed DC electric arc welding, and today we'll be moving on to the discussion on gas welding. However, before we move on to the actual working of gas welding, what we'll do is we will just summarize and have a brief idea about DC electric arc welding. Now, what are the important points that need to be noted in DC arc welding is the first thing is the process what we use generally very commonly is a direct current straight polarity arc welding, and the welding equipment will consist of a full wave rectifier and a step down transformer. That is, in one unit you have both. The current ranges between 100 amperes to 400 amperes, and the voltage is between 70 volts to 100 volts DC. Then cables are used to make the electrical connections, and in this DC RP workpiece is always made the negative terminal, that is the cathode, and the electrode is made as a anode. Now, the electrode which is used in this method of arc welding is consumable and coated. It is coated with flux, and the main function of the flux is to prevent oxidation. It forms a gaseous shield over the actual weld spot or weld place, and hence the oxygen from the atmosphere, the humidity cannot react with the hot molten metal and form oxides. So, flux prevents oxidation, and the electrode is normally held in an electrode holder, and the electrode holder is held in the hand after wearing gloves. Then the workpieces to be joined are to be prepared. The meaning of preparation is the first thing is they are cleaned. The surfaces are cleaned for oil or dust or rust or any such thing. And a small bevel is provided, that is an angular surface, so that there is a void which is created. And once the welding starts, the molten electrode will occupy the space which has been created between the workpieces. The temperature range is about 6000 to 7000 degrees, and localized melting takes place. Even though localized melting takes place, the entire workpiece gets heated up. So, you after the welding is done, immediately you cannot handle with bare hands. And during welding, there is a gap of about 1 millimeter between the electrode and the workpieces, during which there is a formation of plasma, which is a good conductor of electricity. And once the spark is initiated, this spark continues till the end of the welding. Now, protective gear needs to be used, and some of the protective gears are apron, gas shield, eyeglasses, gloves, shoes, etc. And after the welding, the workpiece should be handled very carefully using a pair of tongs. This is because the workpiece is still quite hot, and the gloves should be worn. Once the two pieces that have been joined using this welding method, there is a homogeneous mixture which is formed, and a uniform weld is created. Uh, you can clean the surfaces, you can clean the entire weld initially with a chipping hammer and then with a wire brush, and finally you can use a portable grinding machine in order to grind the surface and make the surface very smooth. Now, welded joints are strong joints, they are permanent joints, and mainly they are used in large fabrication operations such as shipbuilding, trusses, bridges, heavy structures, and so on. Now we'll move on to gas welding. As the name itself suggests, here the heat which is produced by the combustion of gas is used in order to weld the filler material, and this molten filler material is going to occupy the space between the two surfaces to be joined, and then we form the welding. Now, obviously, whenever we talk about gas welding, we need two gases. One is a combustible gas, that is the gas which is inflammable, which can burn, and the second one is a supporter of combustion. Oxygen obviously is a supporter of combustion, and that is one of the main components. The other gas will be some inflammable gas. You can use hydrogen or any other such gas. However, the disadvantage of hydrogen is once hydrogen burns along with the oxygen, then there is formation of water, which is undesirable. And in gas welding, the temperature range is about 3,500 to 5,000 degrees centigrade. Now, the two most commonly used gases in gas welding, wherever it is used, are oxygen and acetylene. and there is a separate consumable non-coated electrode which is used. Here in this case, we call it as either an electrode, or maybe a better terminology will be a filler metal, because only when there are electrical connections we generally call it as electrode, but in this case it is better if we name it as a filler metal. So we use a consumable filler metal, and this filler metal is not coated, it is a bare filler metal. Then you may ask a question, how do we prevent oxidation in this case? So what happens in this case is, there is a flux which is smeared or it is applied on the prepared workpiece surfaces. So this flux can be either borax or wax, or some material which can prevent this oxidation. Now the two gases which are used, that is oxygen and acetylene, are stored in large steel cylinders at a very high pressure, and these cylinders have two things installed on them. One is the regulator and the other one is a pressure indicator. Obviously the function of a pressure indicator is to indicate the pressure of the gases inside. The regulators are used to regulate the amount, that is the flow of gases through the hose pipes. We call them as hose pipes, that is they are basically the pipes which are going to take the gas out. Now these gases, which since they are kept in two independent cylinders, these gases independently are taken. They are taken to a mixing chamber, and they are mixed in the mixing chamber, and then they are taken to the flame torch. And this flame torch, once it is ignited, there is a flame which is produced. So the heat from this flame is used to melt the electrode or the filler metal, as I said, and occupy the space between the workpieces. So the workpieces generally do not melt in this case, as was the case in electric arc welding. It is only the filler metal which melts, and we use either borax or zinc chloride as a flux in gas welding. Then a gas flame, it can be used for welding purpose also, as well as to perform gas cutting. So this is a very interesting feature of this flame. Now if we use a filler metal, then we use it for the welding purpose. If we use only the energy contained by the flame, then we can use it for gas cutting. That is, metal sheets or metal plates can be cut using this flame. Normally if the workpiece have a thickness of up to 2 mm, they are called as sheets. So if they are thin, then we call them as sheets, and if the thickness increases, then we call them as plates. So up to about 5 mm, both sheets and plates can be cut using this heat from the flame. Now this is the schematic representation of the gas welding equipment. Of course you need to practice this sketch also. Here you can see that there are two cylinders, one containing oxygen and one containing acetylene, and we have a regulator. There will be a pressure indicator also, and the pipes which take the gases. So these are called as the hoses, okay, HOSES, and whatever is handheld, this is the mixing chamber. Here there is a mixing chamber. In fact, there will be a regulator immediately after the mixing chamber also. That is, somewhere here you can see that this is the regulator. In some cases what happens is, after you decide what proportion of acetylene and oxygen is to be mixed, then these regulators are untouched. You are going to open them up to a certain level and leave them as it is. But when you are carrying out the welding, there may be an occasion where you may have to extinguish the flame. So instead of using these two regulators, you can use this regulator, which can be used to switch off the supply of the mixed gases, so that the flame gets extinguished automatically. Now then when we have the torch, and at the tip of the torch there will be a flame. Okay, so this is the torch, and at the tip of the torch there is a flame, and this flame is directed on the filler rod. You can see that there is a filler rod, and as I mentioned, the material of the filler rod is the same as that of the base metals. So the filler rod melts and it is going to occupy this entire space. So obviously initially it will be in a molten form. Once you allow it to cool and solidify, it will form a homogeneous mixture, and the two workpieces will get welded together. So this is the basic principle of gas welding. Now these are a couple of features of gas welding. It is a very versatile process, and it can be used in many applications. The cost of operation and maintenance is low. That is, both the gases are relatively cheap in their cost, and the heat source and the filler metal are separated. They are not the same. In the arc welding, the electrode was also the filler metal, hence the heat source and the filler metal were the same. So here in this case, it helps in achieving better deposition of the filler metal. The rate of heating and cooling is slow, and hence lesser thermal stresses are induced. The equipment is portable. You know, you can carry the cylinders and the other equipment. You can dismantle them, disassemble them, and carry them, and then again assemble it wherever you want, and you can use it. So it is portable and multifunctional. The heat from the flame can be used for gas welding, it can be used for gas cutting, it can be used for preheating, and even in brazing. So when we discuss about brazing, we may not be able to completely tell that what gases are used and so on. In brazing, we will only say that a filler metal is used and this molten filler metal is going to occupy the space. But how are we going to melt the filler metal? Actually, we are going to use this flame only. And there are a few disadvantages also. Large sections cannot be welded using this method. Large sections, in the sense, if the thickness is more, then we cannot weld. Then handling and storage of cylinders is not easy, since the gases are at a very high pressure. There is a possibility of explosion of cylinders due to improper handling. They have to be handled very carefully. And the same safety equipment that were used in electric arc welding can also be used here. That is, you can use a gas shield, you can use goggles, and then apron, gloves, etc. The same thing can be used here. Now, based on the proportion of the gases used, with the help of the regulators, that is the two regulators which are here, we can control the amount of acetylene and oxygen which flow through the pipes here. So based on how much acetylene we are letting out and how much oxygen we are letting out, there are three different flames which are produced, and the heat range of the three flames are also different. Even though we say it is 3,500 to 5,000, the range is slightly different for these three flames. So these three flames are seen in the next slide. So in case we have more of acetylene and less of oxygen, so excess acetylene, here you can see that there is excess acetylene. We call it as a reducing or a carburizing flame. This is used to weld aluminum steels and aluminum alloys. Then if oxygen is excess, so in this case oxygen is 0.9% and acetylene is 1%. So in this case, oxygen is 1.5% and acetylene is 1%. That is, oxygen is more. You can see there is a change in the flame also. Here, there is a small inner cone and a big blue flame, and this produces sufficient heat. That is the maximum temperature zone. And in this case, the inner cone is conical in shape and it is slightly smaller in size. And the third one is neutral flame, when there is equal amount of oxygen and acetylene. That is, the ratio is 1:1. So this is used for welding low carbon steels and mild steels. Okay, so this is all about the discussion on gas welding, how it is done, what is the equipment, what are the equipment that are used, and what are the different kinds of flames, then advantages and disadvantages. We will be discussing about brazing and soldering in our next lecture. Thank you very much.